Dear colleagues, I'm Volodymyr Yasny from Ternopil Van National Technical University from Ukraine. So let me introduce my presentation. So the topic of the presentation is to study the stress ratio effect on the functional behavior of shape memory alloys. So shape memory alloys used in a lot of fields like civil engineering, mechanical engineering, biomedical engineering, and so on. So there are and these structures that are based on the shape memory alloys commonly used in the intensive loading, such as cyclic loading, such as dynamic loading, and so on. So, and there is a little bit limited studies of stress ratio effect on the functional behavior of this type of material in stress control mode, in strain control mode. So the aim of the work was to study the effect of stress ratio under low cycle fatigue of pseudoelastic knitting alloy under uniaxial tension. So we study only pseudoelastic behavior, not shape memory effect. So the temperatures to forward and reverse phase transformation was studied using differential scanning calorimetry and was estimated as following. So AF is 9.6 Celsius, so which allow us to study this behavior under the room temperature near 20 Celsius. So the chemical composition also presented here. So it is 55.8 of nickel and 44.1 titanium. So mechanical properties was estimated using American standards F2516, and the following stress transformation was obtained. So to study the stress ratio effect, we used the cylindrical spaceman with a diameter of 4 millimeter, and the frequency for all tested specimens was 0.5 Hertz, and under stress control mode in sinusoidal form. So the minimum stress was 450 and the maximum stress was 550. So two stress ratio was taken into account, 0.1 and 0.5. So totally in each series, minimum 3 specimens was used to study. So these typical hysteresis loops were obtained for each for appropriate stress ratio and appropriate sigma max. So a decrease in the area of hysteresis loops is observed for both stress ratio 450 and 500 megapascals, but at 550 megapascals remain almost unchanged until the failure of spaceman. So this could be explained by the crossing the reverse stress of direct transformation, direct and reverse phase transformation. Also, to present results was used strain-based criteria like residual deformation, residual strain. So this is mainly strain that is not the Martensite strain that could not be reversed to the from austenite to martensite phase, so it's not recoverable strain. Sorry, so it was shown that residual strain grows more intensively during the first 100 cycles, then it has stabilization region or remain constant before fraction, and increase in the stress ratio leads to decrease in strain range of approximately 50%. So similar relationship was obtained also for strain range. Also, energy-based criteria was used to present these results. So dissipation energy was used to compare this data. So increasing in stress ratio was revealed that it worsens the functional properties of shape memory alloys for all spacements, for all regimes, testing regimes, and decrease the dissipation energy in 3 times at 450 megapascals and in 4.2 times at 550 megapascals. Also, it is typical known that pseudoelastic shape memory alloys have the first 50 or 100 cycles like stabilization. So also here is presented results on the 1000 cycle. So 1000 cycle was chosen like stabilization region, and here we use this relationship. So here dependencies between dissipated energy and stress range is could be described by polynomial function. So, and in the when result presents in the from sigma maximum, it clearly shows that it could not be described by one function. So also the loss factor was used to analyze these results, and it was shown that the same values of maximum stress, the loss factor is higher at a stress ratio of 0.1. So this difference increases with the increasing of maximum stress. So also here is presented the results of stress-based criteria on the lifetime of pseudoelastic shape memory alloys, and it is shown that the increasing in stress ratio increase the lifetime of pseudoelastic nickel titanium shape memory alloys by 4.2, between 4.2 and 5.4 times, despite sigma maximum 450 MPa. So it could be explained because 450 MPa, it is the stress that is close to reverse stress between austenite and martensite, and higher stress is more higher than this material could reverse. Also, Young modulus between residual strain is presented, so it's showed quite noisy results, but nevertheless there are some decreasing dependencies on the stress ratio 0.1 and slightly increasing on stress ratio of 0.5. Also, the macrofructography was performed for both stress ratio 0.1 and 0.5, and at minimum stress and maximum stress. So it was shown that on the side surface of spacements, it was shown that the crack-like defects oriented parallel to the fracture surface was revealed, and you could see that on the stress ratio 0.5, this such type of defects are much more than on 0.1. So the conclusion is the following, that the effect of stress ratio was studied, and between the range of 1,900 cycles to 1,500, sorry, cycles, and the higher stress, the fatigue life at stress ratio 0.5 was found to be 4.2 to 5.4 times higher than compared to stress ratio 0.1. So thank you for attention.